All right, Jim. So another new piece of information that's coming out is a really cool partnership that is meaningful to the wireless power and mobile phone industry. So we see that Qualcomm and Renesas announced collaboration on 30-watt Qi-based wireless charging. That's double the power that is currently available under Qi at 15 watts. So this is really meaningful. And it's also meaningful because of the companies that are doing it. So let's start there. So tell me what you think about Qualcomm and Renesas partnering up for this solution.
Qualcomm is the dominant maker of smartphone chips, system on chips for smartphones around the
Mhm.
world. So when they say something, everybody listens. They
Yep.
are in a very dominant position. So when they're pushing something, it's going to get everybody's attention. The fact that they're partnering with Renaissance, formerly IDT, one of the leaders, especially on the receiver chip side, that they're in a also in a dominant position, and they've released their P9412 IC
Yep.
last year that is capable of 30 watts receive power. Marrying those two together is a significant statement that everybody in the smartphone industry is taking notice of.
Yeah, these are, as you mentioned, two very critical IC manufacturers in the space, making a statement that the power level should go up and wireless power is an essential smartphone and other device product. Now, we've worked with Qualcomm and Renesas on multiple different programs. So when they want to do something, it happens. They're very great companies and they're very innovative. And so I'm very excited about this. The thing that it also tells me, let's talk about the Wireless Power Consortium for a little bit and then the Qi standard. The Qi standard right now is limited to 15 watts of power. That's up from 5 watts, so there were some strides made since it first got adopted. But we're still topping out at 15 watts. But we also have a great vantage point into what's going on with, especially the Chinese phone OEM companies. So the Xiaomi's, the Oppos, and the Huawei's, they're really pushing the power in a different way than the Wireless Power Consortium. So it seems like the Wireless Power Consortium is lagging a little bit in power levels. Do you agree with that, or you think I'm seeing it the wrong way, Jim?
No, you're spot on there. It seems like in China there is a wireless, probably actually just a charging arms race going on
Sure.
amongst the different phone manufacturers, and they keep pushing the pedal as hard as they can, not only to increase wired charging rates, but wireless power charging rates as
Yep.
well. Which really, to be practical, they've got to be close to one another. Otherwise, one is going to dominate the other. So from a wireless power standpoint, you're starting to see numbers that are getting close to 80 watts, which
Yep.
is a huge step upward. And so that's where the competition is really coming from. And I think people are taking notice.
Yeah, so I have some notes here that say the Xiaomi 10, for example, has 80-watt wireless charging claims. The Huawei, their whichever newest phone model has does 40 watts wireless. The Oppo 7 does 65 watts wireless, and the One Plus can do 30 watts. So, what does that actually mean for a user of the phone? So we're talking in watts, but when I look at my iPhone or if I look at my Samsung Galaxy, it doesn't tell me what watts are. So what does this higher wattage mean to a consumer?
Well, I think most consumers at some point run into a problem where their battery's low, they're
Mm,
on the go, they need to get out the door quickly. So they've got 15 minutes, 30 minutes to be able to kind of get themselves topped off and moved out, and on with the rest of their lives. So these high charge rates typically enable them to get a sufficient level of charge where they're not going out the door, going from 2% to 12%. They're up to 50, 60% in maybe 20 minutes or 30 minutes.
wow.
A lot of times these wireless chargers are designed because you're generating a lot of additional heat by charging at these fast rates where
Yep.
they may not do this continuously, but they'll do it at least for the start. And so you'll get topped off or moved upward very quickly. And that's a big step forward and something that a lot of users really like.
Yeah, I think the phones definitely charge faster than they used to, even if you're just used to using wired charging. But it's really beneficial when you're low to get a quick boost. And so I can see the Chinese OEMs really going all in on that mode of thinking to a really interesting point where they're using active cooling measures to allow this to happen, meaning things like liquid cooling or fans. And well, people might be used to having a fan running in their laptop sometimes. Um, in general, no designers of electronic products like to have to put active cooling mechanisms into their devices. It's mainly done just because it's the only way to do it. It's the only way to allow the processors to run or allow the charging to go that fast. So it'll be an interesting path forward to see who really wants to push the envelope on transferring a lot of power, and then how will they deal with the heat. And there's some kind of gray area in between, which is a point where you have to tip over to using things like active cooling. Now at NuCurrent, we do designs up into, I think our top design right now that's mass production is up to 125 watts. So that's an area that we have some comfort in. A lot of our designs we do are in the, everywhere from milliwatts up to, tens of watts and now into the low hundreds of watts. But we're facing a lot of that same problem. We have high efficiency systems, but even with that, when you're dealing with hundreds of watts, even if you have a 90% efficient system, you're still dissipating 10 watts somewhere in that. And 10 watts is meaningful. It kind of adds up, doesn't it, Jim?
Boy, you're talking to somebody that has the candelabra 20-watt light bulbs, in my dining room, and I accidentally touched one time. So yeah, those can get really, really hot if there's not a whole lot of place for the heat to go. So as you said, moving some sort of an active cooling fans or some sort of a system that moves the heat away becomes really critical to basically realizing these higher wattage systems. It's just something I think you need. It made me think a little bit about the early days, or actually the PC industry in general. Back in the early days, the 6800 or the original Intel 8086 processors were just basically put on the board. Over time, they put a heat sink on top of them.
Yep.
And now they have these elaborate heat sinks with fans and everything else going on to pull the heat away. But the consumers preferred the power over the additional space it required. So that won out. We're going to see what happens here.
Yep, there's always this push and pull between wanting more power, whether that's processing power or battery charging power, and the heat it generates and what to do with it. So to us, it starts with trying to make the least amount of heat as possible through efficient design and technology. But from there, you still have thermals to deal with, which becomes mechanical, becomes an ID challenge. And these are challenges that almost everyone we work with faces. It's a real mass production issue. And I think it's just really cool to see Qualcomm and IDT pushing the wireless power consortium further. And it's also exciting to see Huawei and Xiaomi and Oppo also working on high power. And I think that this is a big part of the future of wireless charging, is just continuing to get faster charging speed and more consumer benefit.
Yeah, and I think the demand is there for it. So I think it's going to happen.